Today's lesson is exploring the sine and cosine graphs. Okay, we're going to start out with a warm-up here to get us going in what we need to. Our learning objective for today is I can represent the unit circle in terms of sinusoidal functions by graphing two rotations of the unit circle, x-coordinate and y-coordinates. Okay, so I have a graph here. Let's start by stating the degree. How do I know what the degree is? Well, this is from the beginning of the year. So I can look at what is the multiplicity. So when I go across pretty straight, my multiplicity is 1. When I bounce, my multiplicity is 2. I'm going across straight here. So my multiplicity is 1, and I'm going across straight here. So my multiplicity again is 1. So when I add these up, I get 1 plus 2 is 3, 4, 5. So when I add these up, I get my degree is 5. So the parent function for a 5th degree polynomial, in words that's called a quintic. And for an equation that is f of x equals x to the power 5. Next, I want to label the minima, maxima, global minimum, global maximum, and in the interval from -5 to 5. So this is going to be a maximum. This is going to be a maximum. This is going to be a minimum. So this is also the only minimum. So that'll be also the global minimum. And this is the highest of the highest. So this is also the global maximum. And what is the domain? So domain is from left to right. So I have arrows on here, so that means I continue. So my domain, and we're going to write this in interval notation, is from -infinity to +infinity. Range is from bottom to top. Again, I'm going to write that in infinity notation. So I'm from -infinity to +infinity. So this is all real numbers, but I'm writing it in interval notation. Okay, so we have an activity here to see where the sine and cosine curves come from, because we're going to be working with them for 2 more units. And it makes more sense if you actually create the curves. Okay, so if you're in person and you're in my room and you have a sub, you will have the papers printed out. So if you are not in my room or you're at home and you don't have a printer, you are going to just put a blank piece of paper on top of the papers I have, or just sketch it. Okay, we're going to look at, and we are going to put the radians. So here's my unit circle here, and we're going to just put the radians in. So I'm going to just have you go around the circle. So I know this is pi over 6, pi over 4, pi over 3, and keep going all the way around. So 0. So put all of those on there first. So after you label them just in radians first. And then I would just very quickly make sure I am clear in whatever quadrant I'm in. My coordinates are positive or negative. So in the first quadrant, x and y are positive. In the second quadrant, x is negative. Third quadrant, they're both negative. And fourth quadrant, y is negative. All right. Okay, so normally I use like a piece of twine, but since we don't have a piece of twine, you're just going to take a chunk of paper and roll it around the circle, around the radius, and you're going to mark the special angles so that we can lay them out flat on our graph. So you want to start here with a piece of paper, start at 0 degrees, kind of roll it on here and kind of make little X's on your paper where all the special angles are, because we are going to take that piece of paper and lay it flat, going all the way around here. So I'm going to start at the origin and then I'm going to lay my paper flat on here, and then I'm going to mark my markings, right? So you can see I have something that's going to look something like this, okay? And you're going to roll it in the positive X direction, and then you're going to roll it in the negative X direction, okay? And you're going to do that on both the sine and the cosine curve. So these are my angles, are going to be on the X coordinate. Okay, so we got that. So then you're labeling, then you're going to actually write what each of the angles are. Okay, so this first one is going to be pi over 6, pi over 4, pi over 3. So you're going to mark all the angles in the positive and the negative direction. And then you're going to take the radius of 1 and mark that on the y-axis. Okay, so I'm going to let you figure that out. Okay, so for sine I know is cosine of theta and sine of theta. So sine is the y value, or that would be vertical, right? So over here I'm going to do cosine next. So cosine will be horizontal, or x. So I'm starting with the sine. I am going to go measure, so sine is y, so I want to measure perpendicular from here to here and mark on my little piece of paper and then go put this value at pi over 6. So I'm going to put this value. So since y is positive, I'm going to put it above the x-axis. So then I'm going to graph the next one, and it's a little bit bigger. The next one. Okay, so I'm going to let you figure out what it looks like. So if the y value is positive, you plot it above the curve. If the y value is negative, you plot it below the curve. And then after I do all of that, then you're going to connect these all, okay? So you're going to connect it so you can see what the curve looks like. So the curve is made from all the y values, okay? And I'm going to repeat this for cosine. I'm going to do the same thing with the horizontal values. So the horizontal values, this time I'm going to measure horizontally. So here's my special angle. I'm going to measure the x value. And then this is the amount I'm going to plot. So if x is positive, I'm going to put it above the x-axis. X is negative, I'm going to put it below the x-axis. Let's see. Okay, then I have questions that we're going to answer. I have information here that you're going to document on your graphs. And then tomorrow there's a bunch of questions you're going to answer from your graphs. Okay, you should finish all of the sine function today and most of the cosine function. So you can finish the cosine tomorrow and then answer the questions. That's it.